in this video we will look for the different kinds of sets that we have generally in our syllabus. So let us focus on to these sets. So I am explaining them one by one, you kindly go through them. The first one that I have written is an empty set. Empty set, this is also known as null set, or this is also known as void set. Clear? Empty set, null set or void set, they mean same. How they are represented? They are represented by the sign phi. This is the sign phi. P-H-I, phi. This is represented by phi. Or an empty set like this. Just like you write down any set as set A, set B, capital letter, set A, set B, set C, like that. Set N for natural, set R for real, set Q for rationals, like that. So similarly, set phi for empty set. So we understood that this is a kind of a set, as the name suggests, that these sets won't comprise any element, any single element. They will not be having any single element in them. Why is it so? That is the reason why they are called empty sets. Like for example, if I say that suppose find the number of days in the week when the sun rises from west. Number of days in the week when the sun rises from west. So you will say sun never rises from west. So if you try to find out the weeks in which, or the days in which the sun is rising from the west, you will not find out a single day. This is just similar to those events in the probability which we used to say impossible events. The events which are impossible to happen. So if those events are to be categorized as sets, suppose while the criteria of set is being determined, they are determining a sort of criteria wherein you find out that the event is impossible to happen. So you can simply say that those sets would be termed as what? Empty set. Clear? Now this is very well to be understood that they are represented by phi. So when you are writing down phi, you will not put braces. The elements are put inside the braces. The set is not put inside the braces. So that means phi should not be put inside the braces until or unless there are separate criteria we will see later on. But till that time you can say phi should not be put inside the braces. Till then. And this is what? This is another representation of void set. That means what? You will open the brace and then you will close the brace, and there are no elements in between them. Now this shows that the set is empty. Clear? Now there are finite and infinite sets. Same, the name suggests finite, that means sets which are having finite number of elements. Like the sets we have seen till now. Most of them were what? Finite sets. That means they have got an end. They will end somewhere. There are not infinite elements inside it. So had there been infinite elements, like for example, set of naturals. Now set of naturals is what? Represented by capital L. Now what are the elements in that set of naturals? 1, 2, 3, 4 till infinity. So 1 to infinity. So how many numbers are there if I ask you? So you will not be able to determine it properly. You will simply say, sir, there are infinite numbers. That is the reason why we are calling it infinite sets. And finite sets having finite number of elements. Equal sets. Two sets are said to be equal when they have same number of elements. This is the first criteria. Clear? That the elements must be, means number of elements must be same. And second, every single element of a given set must be is equal to every single element of the other set. That means what? Suppose if I ask you that this means I need to compare 10th A and 10th B, or say 11th A and 11th B. So if I am comparing 11th A and 11th B, so first of all I'll see that if the sets are to be equal, then the number of elements in those sets are to be equal. That means I'll go for the attendance register and I'll see that the number of students present in each and every class. If the number of students are same, that means 11th A comprises of 40 students, B also comprises of 40 students. So okay, fine. Now there is a criteria, the first criteria is met. That means all the elements are same. Now I'll see that every element of one set, say 11th A, is equal to every other element of the second set, that is B, 11th B. So I'll put up every single students one by one of 11th A, and I'll see that whether that student is there in 11th B or not. If he or she is there, which is practically impossible, because one student at a time can be in one class only. So in that criteria I can say okay fine, 11th A and 11th B are not same. But suppose if I give you a set like this, say a set having 1, 2, 3, 4, and another set I am giving you like 4, 2, 1, 3, like this. Now if I ask you, are the sets equal? So first you will count that the number of elements here are 4, here also it is 4. So that means yes, the first criteria is met. Second, now in second case you will see that the first element 1, is 1 there in this particular set or not? Yes, it is there. So 1's criteria is met. Second 2, yes, 2 is also there. Then 3 is also there. 4, then 4 is also there. That means the sequence or order in which they are expressing themselves in both the sets, the sequence is not important. The sequence of the numbers are not important. What is important is that whether every single element of one set is found in the other set also or not. If it is there, then you can say okay fine, the sets are said to be equal. And what about equivalent sets? The equivalent sets, they fulfill the criteria of the first point only. That means number of elements must be same. That means if 11th A comprises of 40 students, 11th B also comprises of 40 students, but the students there are different. So that means they are not equal sets, but yes, they are equivalent. Why equivalent? Because number of elements are same. So 2 or more than 2 sets having the same number of elements are said to be what? Equivalent sets. This is clear? Please pause the video to note it down. Now we'll look for one more thing, that is order of the set. This I must have told you earlier before explaining this equal sets and equivalent sets, but okay, that is fine. Order of the set means what? Order of the set is also known as cardinality. Cardinality of a set. Clear? But what does this mean? It means that the number of elements in a given set, number of elements in a given set, that is what the order of the set represents. How it is written? It is written as, say I am being given set A as A, B, C, D, E. This is there. So I will say order of A. So I will write down order of A like this. This is order of A. N of A. That means number of elements of A is given as what? How many elements are there? 1, 2, 3, 4, 5. We will write down 5. So number of elements of set A is 5. So this thing is called number of elements in set A. So instead of saying this thing, you can say what is the order of A, or you can say what is the cardinality of A. Means say. And what are the cardinal points? A, B, C, D, E. There are 5 cardinal points in the given set. That means the set A comprises of 5 cardinal points. These elements are said to be what? Cardinal points. What are the cardinal points? A, B, C, D, E. These are the cardinal points. Point understood? So this is order of the set. Please